class because many students are unable to attend the class and they are requesting the recorded class. So for this purpose, I am recording the classes. Yeah. So coming to evaporation, the main concept of evaporation we will discuss, and we'll discuss some terminologies in evaporation like free moisture content, FMC, and other kind of things. Then we will go into the factors affecting evaporation, and then we will discuss certain equipments used in evaporation in this class. If possible, we will jump into the distillation topic also. Coming to evaporation, in last class I have asked you the question regarding the difference between evaporation and drying. So can anyone give me the difference between the evaporation and drying? Yeah. What is what happens in evaporation and what happens in drying?
Yeah, wait.
Mazhar, please, can you off your mic?
Okay.
Thank you. So the major difference between the product of evaporation and drying is, in drying you're going to get the completely dried product, whereas in evaporation you are going to get concentrated product. That's the basic difference. And evaporation is generally a slow vaporization of liquid process, right? Condensation also takes place here. And concentrated product, if you want, will go for evaporation. There are a lot of objectives of evaporation. It reduces the bulk content, it reduces the weight of the fluid, and removes large amount of water and moisture. Okay, so this is the major objective of the evaporation. Coming to applications, there are a lot of applications in food industries, cosmetic industries and pharmaceutical industries, even in cloth, chemical industries, textile industry, paper industry also we are going to use this evaporation techniques. Now, the most important thing is factors affecting evaporation. I hope many of the students who have done their B Form and diploma remember the experiments in pharmaceutical engineering and physical pharmacy practicals. We have an experiment on factors affecting evaporation. We will do this experiment basically by selecting different type of containers like surface area. We'll take big beaker, small beaker, intermediate beaker in one way. In other experiment or on other constraint, what we'll take different concentrations of the liquid and at different temperatures, and all these factors we will change and we will see how evaporation is being affected. It's well known and very simple method, that if the surface area is bigger, then the rate of evaporation will be faster. అందరికీ తెలిసిన విషయమే అంటే అది generally surface area plays a vital role in evaporation. That's why in kettles, in thermoflask, in other things, surface area is too small in order to slow down the evaporation. Whereas if you want to evaporate faster, you need to transfer the product into the wider products. And remember, especially in equipments used for drying, we use tray dryers. In tray dryers, evaporation kosam surface will be the bigger one. Next, temperature. The temperature used is also an important factor, and it also defines the rate of and it also what can we say that affects the rate of evaporation. So the increase in temperature also plays a vital role. Next, presence of humidity. Generally evaporation decreases with increase in humidity. So this factor you should remember. Temperature గుర్తుంటుంది, surface area గుర్తుంటుంది, కానీ హ్యూమిడిటీ కూడా గుర్తుపెట్టుకోవాలండి. Increase in humidity will decrease the rate of evaporation, and at a particular temperature the air cannot hold more than definite amount of water vapor. This is the reason why more humidity decreases the rate of evaporation. So while evaporating, we need to keep in mind about the humidity also. Next, speed of wind. I hope you remember in dryers and evaporators there are also fans to circulate the hot air uniformly. So speed of the air also plays an important role. Speed of the wind also plays an important role in evaporation. Next, nature of the liquid, viscosity of the liquid, concentration of the liquid also plays a vital role in evaporation. So please note down the factors affecting evaporation. They can ask in question like which among the following is not the factor in rate of evaporation and ippachandi. So surface area, temperature, humidity, speed of the wind, and nature of the liquid. Nature of the liquid lo Viscosity plays an important role. Volatile, non-volatile nature, and concentration also comes in the picture. So please note down. Switch on your cameras and show me that you are noting it down. Yes? Yeah. Thank you. Shiva, thank you. Mazhar, thank you. Others, Manogna. Srikar? Yes, thank you. Yeah, thanks a lot. So this give me some confidence that you people are listening the class. Thanks a lot. Next, the basic thing: difference between evaporation and distillation, difference between evaporation and boiling, difference between evaporation and drying. In the why we are seeing these differences? The first reason here is in all these unit operations, evaporation, distillation, boiling, and drying, we are using heating as a source. So, what is the major difference? In evaporation, the process of transforming liquid into vapors under the influence of heat is taking place. But in distillation, these vapors are condensed back, right? Distillation is a purification technique. So that's the basic difference. And the second difference in evaporation, it occurs only at the surface. But whereas distillation, it does not occur in the surface. Entire bulk flow ida jarugutundi. Next, in evaporation, we can see liquid vaporizes below boiling point. No need to reach to the boiling point. But in distillation, it should reach the boiling point.
Compulsory is a boiling point.
Yeah, evaporation is very slow process, whereas distillation is rapid process.
Rapid process.
Yeah, evaporation is not a separation technique in the Japan. No. Distillation is a separation technique. You can separate easily different substances. Like in distillation topic, we will learn. Right? We can separate the different boiled substances depending on their boiling points in distillation. So those are the basic differences in evaporation and distillation. Compare the evaporation with the boiling and evaporation takes place at all temperatures, but boiling takes place at definite boiling temperature only, boiling point only. Evaporation may change during temperature may change during evaporation. Suddenly cool అవుతూ ఉంటుందంటే because of the vapors, but temperature does not change during boiling. Evaporation takes place only at the liquid surface. ఇందాక డిస్కస్ చేసిన పాయింట్ ఇక్కడ entire liquid get boils. Evaporation rate depends on free liquid surface area, whereas boiling rate depends on, independent of the surface area. Ground bottom flash surface area ఎంత ఉంటుందండి చాలా తక్కువ ఉంటుంది external surface area, but still boiling takes place. So surface area has no factor influencing the boiling point, whereas surface area plays a crucial role in evaporation. So these differences తెలియాలి. కొంచెం ముందుకు వెళ్తే అండి evaporation and drying ఇది చాలా ఇంపార్టెంట్. చూడండి evaporation, removal of large amount of water from the solution, whereas drying, removal of all the water and converting into the solid or liquid or glass. That's important. Small amount of waters are removed and it converts into drying. Generally liquid గా ఉంటే దాన్ని డ్రైయింగ్ కోసం చేయమంటే సాలిడ్ లోంచి స్మాల్ అమౌంట్ ఆఫ్ వాటర్ ని అంటే కంప్లీట్ వాటర్ ని రిమూవ్ చేయడానికి డ్రైయింగ్ వాడతాము. Then evaporation, concentrated thick syrup liquid is formed and a concentrated product is obtained, whereas in drying, solid product is obtained. Evaporation, removal of water by boiling the solution. Drying, removal of water by boiling below its boiling point. Drying law, there are a lot of equipments. Can you suggest me the one equipment which we use for drying thermolayable substances, like used in vaccine preparations, please? We discussed during introductory class. Yeah, exactly. Freeze dryer. Lyophilization is the principle and technique involved there. And in that case, what we are going to do, we are not increasing the temperatures at higher levels, which is preventing thermolayable substances. And also it is helping us in preparation of freeze-dried vaccines, attenuated vaccines. Next, water is removed as a pure water vapor mixed with other gases due to unavoidable leaks in evaporation, whereas in drying, water is removed by circulating hot air or some other gases over the material in order to carry away the water vapor. The last thing in evaporation, final stage, final stage of preparation, whereas in drying, it's also the final stage of the preparation, dried product. So these are the certain differences between evaporation and drying. Just a minute. Pawan, parent వచ్చారు. Then let's jump into the equipments which we are going to use for evaporation. I know I am little bit faster, but what can I do? We have very less time. Unit operations, మనం already 3 classes కంటే ఎక్కువ తీసుకున్నామండి. We need to gear up. We need to move faster because there are many other parents. There are many other topics on which we need to discuss a lot, like especially tablets is there, parentals is there, capsules is there, and jurisprudence is also there. So I am little bit rushing on all these small topics. Next Sunday, evaporation equipments aiming javato. We discuss steam jacketed kettle, very important. Next, horizontal tube evaporators, vertical tube evaporators, climbing film evaporators and falling film evaporators, forced circulation evaporators, and multiple effect evaporators. ఇందులో అన్నిటికంటే ఇంపార్టెంట్ నన్ను అడిగితే మల్టిపుల్ ఎఫెక్ట్ evaporator than climbing film evaporator. Why multiple effect evaporator is very important? Because in multiple effect evaporator, energy can be conserved. The, the energy or the heat used for one evaporator can be used for multiple evaporators. So we can use it. So that is the importance of multiple effect evaporator. Good evening, sir. So please note down different evaporators. Steam jacketed kettle, horizontal tube evaporator. Noted? Yes? Yeah. So let's start with the steam jacketed evaporator. So you can see the construction as shown in the figure. We have a steam jacketed kettle. Each kettle maintains the temperature because of the steam we are passing into it. So this is the inlet for the steam, you can see, and this is the vent from where the steam comes out. And this is the outlet for the product where the concentrated product will come out. Simply in this steam jacketed kettle, we are going to fill with the product which we are supposed to be evaporated. Then we will evaporate it by passing the steam from the steam inlet present in this jacketed kettle. So principle student, principle is very easy. The evaporation pan on the jacketed kettle contains aqueous extract subjected to steam, which provides heating to the pan. Steam is used to heat the pan. This is the main good. This heat gets transferred to the aqueous extract by conducting and convection. So conduction, only heat transfer, we will discuss about the conduction, convection and radiation. As a result, extract temperature raises and tendency of the solvent molecules to convert into the vapors. See the construction, very simple as shown in the figure. Steam jacketed kettle is a hemispherical structure with an inner pan called kettle enclosed with an outer pan called jacket. So in this case, the inner pan, now I am trying to mark it with the red color, you can see. This inner pan is kettle and this outer pan is a jacket. Hope you understood. So this is the construction, right? And for small scale uses only, we are going to use steam jacketed kettle. Generally, the material used for steam jacketed kettle is copper. ఇది note చేసుకోవాలి. ఇక్కడ చూడండి, no like what can we say, dimensions are given for the kettle because the kettle size is varying. So the only thing to be focused here is it is double layered. Inside layer is called kettle, outside layer is called jacket, and the second thing is it's made up of copper. Annually పెట్టిన 2.5 టెస్ట్ పెట్టి మాట్లాడదాం టెస్ట్ పెట్టి టెస్ట్ పెట్టి ఎలిజిబుల్ కాదా చెప్పండి. రైట్. సో కమింగ్ టు material used here is copper. Next, we can say copper may dissolve on evaporating acid material. So, tinned copper is used in some cases, and in some cases, in such preparations, iron can also be used. So, three material we are using: copper, tinned copper, and iron. Okay. So, the top portion of the jacket has an inlet for the steam, already cheppunnam manam, and an outlet for the steam, and there is a product collection concentrate, and ikkada nunchi condensate vastundi. So this is simple working. So గుర్తుపెట్టుకోవాల్సింది copper, tinned copper, and iron are material used in preparation of steam jacketed kettle, and generally small batch products కోసం we are going to use this one. Okay, and the maximum capacity what we can use in steam jacketed kettle is 90 liters. Please note it down. 90 liters. So there is an example also given. Licorice extract plant drugs extracts కోసం concentrate products కోసం we are going to use steam jacketed kettle. Yeah, there are a lot of advantages and limitations also. Small equipment and so I'm not focusing on it. Next, it's a very good equipment, horizontal tube evaporator. ఎంతమంది ఇంట్లో గీజర్ ఉంది, ఎంతమంది గీజర్ గురించి తెలుసు? గీజర్ ఎలా వర్క్ చేస్తుంది చెప్పండి బాయ్స్. చలో, Shivakrishna garu, Srikar, Mazhar, explain me about geyser.
సార్
How geyser is going?
గీజర్ లో హీటర్స్ ఉంటాయి సార్. ఎప్పుడైతే
Yes.
మనం ఇన్లెట్ నుండి వాటర్ ఇచ్చినామో ఆల్రెడీ హీట్ అయిన కండెన్సర్స్ మన హాట్ వాటర్ ని హాట్ వాటర్ లో మారుస్తాయి ఇన్లెట్ నుండి.
Yes.
దాని అవుట్లెట్ నుండి మనం ట్యాప్ లోకి తీసుకోవచ్చు.
Yes, very good. So మీకు పైన ఇక్కడ ఒక ఎక్విప్మెంట్ కనిపిస్తుంది చూడండి, horizontal tube evaporator. Doesn't it like look similar to the geyser? The only difference
Yes, sir.
is akkada we are using electricity to heat, ikkada we are using steam to heat. That's the only difference. See, the entrance here is steam because industries lo electricity vaadte costly affair. Steam vaadte it is cheaper. So
Okay.
we are going to use steam. Water vaadtam, water ni heat chesi steam ni vaadtam. So in horizontal tube evaporator and also in vertical tube evaporators, these horizontal tubes are there. Hollow horizontal tubes, and in these tubes steam is being passed, and this steam heats on these tubes, and these tubes will heat the product which is in contact with these pipes. Let's see the principle. In horizontal tube evaporator, steam is introduced into the horizontal tubes, dipped into the liquid to be evaporated. Steam in the tubes provide heat to the liquid outside the tubes. The liquid get heated up, thus evaporating the solvent which escapes from the top of the evaporator. So the main inlet student ikkada steam inlet. Steam goes in, heats up, and went to let out the heat steam. ఇక్కడ కండెన్సేట్ స్టీమ్ కండెన్స్ అయిపోయినాక ఇక్కడ పడిపోతూ ఉంటుందండి. ఆ స్టీమ్ ఇటు నుంచి రావడం వల్ల ఈ పైప్స్ అన్ని హీటప్ అయిపోతున్నాయి, అండ్ ద మెటీరియల్ ఇన్ కాంటాక్ట్ విత్ దిస్ పైప్ is heating, and the solvent to be evaporated is going out from this solvent outlet. So ultimately what's happening, I am getting concentrated product in this equipment, and that concentrated product I am collecting from this bottle. That's it. Very simple, very easy. What points to be remembered? ఇక్కడ డైమెన్షన్స్ ఇచ్చారు. యావరేజ్ సైజ్ రేంజ్ is from 1.8 to 2.4 meters in diameter, right? And the length is 2.4 to 3.6 meters. So diameter length ఇచ్చాడండి. సో ఈ డయామీటర్ వచ్చేసి ఎంత ఉంటుంది 1.8 నుండి 2.5 మీటర్స్ దాకా ఉంటుంది. లెంత్ అంటే హైట్ వచ్చేసి 2.4 నుండి 3.6 meters దాకా ఉంటుంది. సో ఇట్ హ్యాస్ అ conical or dome shaped top. ఆల్రెడీ చూసాం మనం. కన్స్ట్రక్షన్ is as shown in the figure. Steam compartment is present in the lower part of the body. చూసాము. One end of this compartment has a steam inlet and other end has an outlet. At the bottom of the ends of the these portions, condensate outlet is there, where condensed material will be falling down. Already we have seen 6 to 8 tubes untai. They can be increased or decreased. That's not at all in D. So this is horizontal tube evaporator. So points to be remembered here: dimensions. Next, how tubes are arranged, how heat is transferred, from where the product is collected, from where the steam is being sent, and from where the vapors are being expelled out. So these things should be focused in horizontal tube evaporator. Clear? సి మీకు ఎగ్జామ్లోకి వెళ్ళి డిస్క్రిప్షన్ ఏం రాయడం అవసరం లేదు కాబట్టి వీఆర్ నాట్ గోయింగ్ ఇన్ డీటెయిల్, వీఆర్ జస్ట్ సీయింగ్ ద అవుట్లైన్ ఆఫ్ ద ఎక్విప్మెంట్. ఓకే?
Yes, sir.
Yeah, clear with the horizontal tube evaporator?
Yes, sir.
Yeah, thank you. Next, there are a lot of merits and demerits and uses. ఇవి ఫోకస్ చేయాలండి కొంచెం. Horizontal tube evaporator is used for non-viscous solutions. ఇది ఇంపార్టెంట్. విస్కస్ సొల్యూషన్స్ కి వాడలేము. Which one evaporations do not deposit scales and crystals? Example, cascara extract. Merits: cost per square meter of heating is very less. It is easy to install and the tubes can be easily removed. Demerits: it requires large heating area and it is not used for thermolabile material and crystalline products. గుర్తుపెట్టుకోవాల్సినవి: thermolabile material not suitable, crystalline products not suitable, large heating area అవసరం. These are the limitations. Okay, right? And viscous substances kuda not suitable. So please note down the limitations note cheseskunte we'll move forward to the climbing film evaporator. Very interesting evaporator. My old students remember this. I don't know about the new people, but climbing film evaporator is a little bit interesting. You need to understand it. If you are done with the horizontal film, horizontal tube, then we'll go to climbing film. So shall we move?
Yes, sir.
Yeah. So coming to climbing film evaporator, have you ever, girls question, have you ever seen boiling of milk? Milk పెట్టేసి మీరు మర్చిపోయారు ఇన్స్టాగ్రామ్ లో, ఏమవుతుందండి? పొంగిపోయేది చూసారా?
Yes, sir.
ఎందుకు పొంగుతుంది? మనకు అనుకుంటే వీడు పిచ్చోడు అడ్డమైన క్వశ్చన్లు అడుగుతాడు కదా. మనం హీటింగ్ వల్ల మరి వాటర్ పొంగవే, పాలు ఎందుకు పొంగుతాయండి? ఎస్, రాజమణి గారు, ఆఫ్రీన్, మనోజ్ఞ. In fact, boys also should know the answer. Why?
అంటే అట్టు రావాలి కదా సార్, ప్రోటీన్ కోగులేషన్ అవ్వాలి.
లేదండి, నేను వాటర్ హీట్ చేస్తున్నా, మిల్క్ హీట్ చేస్తున్నా. వాటర్ హీట్ చేస్తే పొంగి బయటికి రావట్లేదు. మిల్క్ హీట్ చేసినప్పుడు ఎందుకు పొంగి బయటకు వస్తున్నాయి?
Boiling point of water is
వాటర్ కి మిల్క్ కి ఫస్ట్ డిఫరెన్స్ విస్కాసిటీ. మిల్క్ ఇస్ విస్కస్. ఎస్, యా. సెకండ్ థింగ్, క్లైంబింగ్ ఫిల్మ్ ఆపరేటర్ లో అలానే జరుగుతుంది. వాట్స్ హ్యాపెనింగ్ when you are boiling the milk is, see, I'm trying to illustrate here. I don't know whether you will understand or not. ఇప్పుడు నేను ఇక్కడ బౌల్ వేసాను అనుకుందాం. ఇందులో ఐఎమ్ ఫిల్లింగ్ ఇట్ విత్ పింక్ కలర్ మిల్క్. చలో, ఎందుకంటే వైట్ కనిపించదు కాబట్టి ఇక్కడ వైట్ మీద వైట్, పింక్. ఇది దిస్ ఇస్ ఫిల్డ్ విత్ మిల్క్, రైట్? నా వాట్ వీఆర్ డూయింగ్ ఈజ్ హీటింగ్ ఇట్. సో కింద మంట పెట్టేసావు, గ్యాస్ లో హీట్ చేస్తావు. ఏమవుతుందంటే ఫస్ట్ దిస్ సర్ఫేస్ ఆఫ్ దిస్ బౌల్ విల్ హీట్ అప్. అవునా?
Yes, sir.
yes.
If you observe what happens, is in this borders మీకు చిన్న చిన్న బబుల్స్ లాగా కనిపిస్తాయండి పాలు పొంగే ముందు సౌండ్ స్టార్ట్ అవుతుంది చర్ 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 అని సౌండ్ స్టార్ట్ అవుతుంది సో the liquid which is in contact with the wall, hot surface, first evaporates and forms into this small bubble. This bubble entraps the liquid in it. So ఈ పాల లిక్విడ్ కొంచెం పైకి వెళ్తుంది మళ్ళీ ఇది ఎవాపరేట్ అయిపోగానే మళ్ళీ ఇంకో బబుల్ ఫామ్ అవుతుంది మీరు ఈసారి పాలు వేడేటప్పుడు గమనియండి అగైన్ ఈ లిక్విడ్ మన పింక్ లిక్విడ్ ఏదైతే ఉందో సో కాల్డ్ మిల్క్ it's climbing up through the walls. Okay. It's climbing up through the walls because of entrapment of liquid in the vapors, in the bubbles. ఇందులో ఎంట్రాప్ అవడం వల్ల సో స్లోగా కొద్దిసేపు అయినాక ఏమవుతుంది ఎండ్ ఆఫ్ ద స్పీకర్ రాగానే ఫిల్మ్ అంతా క్లైమ్ చేసి పడిపోతుంది సో వీఆర్ కాలింగ్ ఇట్ క్లైంబింగ్ ఫిల్మ్ ఎవాపరేటర్ సో పొంగుతుంది సో దానికి మేజర్ రీజన్ మరి నీళ్ళు ఎందుకు పొంగవన్నారు సార్ పాలు ఎందుకు పొంగుతాయంటే విస్కాసిటీ ఇస్ వన్ ఆఫ్ ద మేజర్ రీజన్ వై మిల్క్ ఈస్ బీన్ లైక్ ఏమంటారు దాన్ని పొంగడాన్ని ఇంగ్లీష్లో ఏమంటారో ఐ డోంట్ నో ఎగ్జాక్ట్లీ ఐ డోంట్ రిమెంబర్ అమ్మా ఎవరేదో అంటున్నారు సో క్లైంబింగ్ ఫిల్మ్ ఎవాపరేటర్ లో ఏమైతుందంటే అండి లెట్స్ నౌ ఈ కాన్సెప్ట్ బ్రెయిన్ లో పెట్టుకొని ఎక్విప్మెంట్ ని చూడండి క్లైంబింగ్ ఫిల్మ్ ఎవాపరేటర్ లో యూ హ్యావ్ దీస్ హారిజాంటల్ ట్యూబ్స్ ఈ హారిజాంటల్ ట్యూబ్స్ ని హీటప్ చేస్తాం బై సెండింగ్ స్టీమ్ సో ఐఎమ్ సెండింగ్ లుక్ ఐఎమ్ రెడ్ కలర్ ఐఎమ్ సెండింగ్ స్టీమ్ ఇన్ దీస్ ట్యూబ్స్ సో ఈ ట్యూబ్స్ అన్ని హీటప్ అయిపోతున్నాయి సో the surface of this entire tube is got heated up. Now, what's happening? I am sending the liquid from the bottom. ఇంతసేపు పైనుండి పంపించామండి liquid feed. Now I am sending it the liquid from the bottom. So when my liquid comes in contact with these hot pipes, what happens? The surface of the liquid which is in contact with the surface of the pipe evaporates and forms into small bubble. And this bubble entraps the liquid. So malli inko bubble form aitundi, malli liquid entrapped aitundi. Again and again this procedure is repeated and liquid is traveling up. So climbing above the film. So I am calling it climbing film evaporator. Let's see the principle, very simple. The climbing film evaporator, steam is supplied to the external surface of the tubes. Then preheated feed is introduced from the bottom, which flows up through the heated tubes, flowing up to the heated tubes. The overheat transfer coefficient of preheated feed is high due to which the liquid heats up rapidly. Already manam preheated liquid పంపిస్తున్నాం కాబట్టి the liquid is heated up rapidly. Preheated ఉంది కాబట్టి, right? So the liquid near the walls, నేను చెప్పిన point, vaporizes, forming small bubbles, which combines into large bubbles. These bubbles travel up in the tube along with the slug. Slug ante ikkada milk or the liquid to be operated. The liquid film below that, the liquid film is formed and it's blown up on the top. That's the different concept. So this is how your milk is being boils when you are heating it up. So ఈ రోజు కిచెన్ లోకి వెళ్ళి కనీసం ఒక 6 లీటర్ పాలు వేస్ట్ అయినా పర్లేదండి, దాన్ని గమనియండి ఎలా పొంగుతుంది, ఎందుకు పొంగుతుంది, మరి ఎక్కువ డైల్యూట్ చేస్తే మరి మిల్క్ పొంగుతుందా, విస్కాసిటీ తగ్గిస్తేను, బాగా చిక్కగున్న మిల్క్ ఎక్కువ పొంగుతుందా, అలా పొంగడం ఆపాలంటే ఏం చేయాలి, గ్యాస్ కట్టేయాలి లేదా అందులో వాటర్ యాడ్ చేయాలి లేదా బాయిలింగ్ పాయింట్ తగ్గియాలి లేదా మూత పెట్టాలి, రైట్? సో దాట్స్ వాట్ వీఆర్ డూయింగ్ హియర్. ఇక్కడ మూత పెడుతుంది. So there is a deflector which breaks this bubble, big bubble, and allows that concentrated product to be collected from this place. This is climbing film evaporator. I don't know whether any of your teacher has compared this climbing film evaporator with the boiling of the milk in your career or not, but this will help you in remembering a lot. See the construction. నేను ఏదైనా తప్పు చెప్తే చూడండి క్లియర్ గా and catch hold of me. See clearly చెప్తుంది ఇక్కడ, the liquid near the walls vaporizes, forming the small bubbles which combines into large bubbles. These bubbles travel up in the tube, forming a film and entrapping the slug. So we are calling it climbing film evaporator. Got it?
Yes, sir.
Let's see the construction. Climbing film evaporator consists of heating unit with steam jacketed tubes, which are long and narrow and held up in two places. We have seen this at the top of the paper
horizontal
head.
tubes.
Yeah, the deflector. ఇది deflector and final. Deflector ఏం చేస్తుంది మొత్తం బయటికి వెళ్ళిపోకుండా it prevents the uh, deflector or entertainment separator is present. The evaporator carries on inlet for the steam. Two outlets, vent outlets, ఇవన్నీ construction లో చెప్పుకుంటాం. Working లో again same thing. చూడండి, heat from the steam jacket is transferred to the walls of the tubes. Liquid which vaporizes form the small bubbles. These bubbles fuse to form the large bubbles, and which, while moving up the tube, entraps the slug or the liquid. సేమ్ మీరు ప్రిన్సిపల్ లో చదివిందే మళ్ళీ ఇక్కడ కూడా ఉంది. కానీ ఒకటి గుర్తుపెట్టుకోవాల్సింది ఇక్కడ అగైన్ డైమెన్షన్స్ 0.6 meter to 1.2 meters. The height of the liquid column is kept 0.6 meter to 1.2 meters above the bottom of the tube. ఒక్క డైమెన్షన్ గుర్తుపెట్టుకుంటే ఇక్కడ మిగతాదంతా old. This is climbing film evaporator. Coming to users, it is used for concentrated thermolayable substances. Remember, steam jacketed kettle cannot be used for thermolayable substances. Horizontal tube evaporator cannot be used for thermolayable substances. But climbing film evaporator can be used for thermolayable substances. Note it. It can also be used for evaporating clear, foamy, and corrosive liquids. మనం చెప్పుకున్నాం steam jacketed liquid, kettle and horizontal tube evaporator are not used for corrosive liquids, but this can be used, right? So there are a lot of demerits and large head space is required. Maintenance and cleaning is like very cumbersome process. Expensive with complicated construction. Suitable for viscous salting, sorry, not suitable for viscous salting and scaling liquids. Viscous liquids ki idi kuda suit kaadu. So these are the limitations of climbing film evaporator. So any doubts in climbing film evaporator?
No, sir.
Everybody have a look. It's so simple. Again, we are using steam here for evaporation. Feed is coming from the bottom. You can clearly see. Steam is entering from this side and heating these like steam tubes. And the liquid in contact is coming in contact with these hot tubes, preheated liquid. So they're forming vapors, are forming small bubbles. These bubbles are connecting with each other to form the big bubble, and they are entrapping the liquid in it, and liquid is simply traveling up. So trust me, once go into the kitchen after the class, believe me, once observe how milk is boiling, then you will understand
Sir,
clearly.
concentrate.
Sir, concentrated filtrate
Sir,
is collect.
product
Product is collect. See, this deflector is there, na?
product level is decreasing or medium, sir?
Product level obviously decreases, right? So this deflector, what this deflector is doing, it's breaking that bubble, and the hot concentrated product is collected here. The concentrated product. Okay. Clear?
Okay.
Next equipment. Next equipment, very important equipment, and falling film evaporator మనకు లేదు. Forced circulation evaporator. See, there is minute difference in forced circulation evaporator and climbing film evaporator. ముందే చూపెట్టేస్తున్నాను. A minute difference is pump. In climbing film evaporator, we are not using any equipment to push the liquid on the top layers, but in forced circulation evaporator, we are going to use this pump to push this liquid. So that's important. Okay, so let's have a look at forced circulation evaporator. In forced circulation evaporator, the liquid requires additional mechanism, that is
Agitate.
agitation of its movement by using the pump. So liquid is circulated through the tubes using high pressure pump. ఇది లేకుండే దాంట్లో. As a result, the liquid does not boil because boiling point of it is suddenly fallen down. So దీని వల్ల it is used in thermolabile substances. Observed when the liquid leaves the tube and enters the vapor head, lead to the flashing. ఇది important point అండి. You need to understand this concept properly. Superheated liquid. Generally, high pressure nundi low pressure region కి రాగానే sudden flashing will take place. So sudden evaporation takes place at low temperatures. Here in low places, here pressure is high pressure is maintained, and here low pressure is maintained. So sudden change in the pressure is causing the flash evaporation. This point should be remembered. See again, ఈ ప్రిన్సిపల్ వచ్చేస్తే వర్కింగ్ మెకానిజం తెలిసిపోతుందండి. In this forced circulation evaporator, we are using high pressure pumps to forcefully circulate the liquid. Ikkada daaka okay na? Then
Okay.
as a result of this high pressure, the boiling point suddenly falls down in high pressure, right? This is absorbed, and when the liquid leaves the tubes, pressure suddenly drop avadam valla